Okay, friends, so what we're going to do here, I know we saw 18 trials in the Jimmy Fallon videos, plus the one of me and Kale, but I want more data. I want to make sure we drive home the point of what that 1/3 or 2/3 chance, the 8/12 or the 4/12 chance, the 6/18 chance. I want to drive home the point of what those mean in this video here. So what we're going to look at is a Monte Carlo simulation in Excel of the raw and hard-boiled eggs. You have to kind of stretch your imagination a little bit. This right here is a dozen eggs. Every time I re-randomize, I get a new position of the 4 raw and the 8 hard-boiled eggs. Hopefully you're seeing that every time I re-randomize it, the eggs are moving around. Now, some of you might be wondering why this one right here has a dark border around it. And this is something I noticed as I was watching the guests on Jimmy Fallon always grabbing their first egg. Here are the results of what I saw from which egg the guests picked. Not if it was hard-boiled or raw, but which egg they picked. And you might notice something. A disproportionately large number of them picked this egg right here. So because of that, I decided to code my Excel spreadsheet like this. I'm going to randomize all the eggs through the carton, but I'm only going to pay attention to the characteristic of that egg because I realized it really doesn't matter if I'm going to repeat this experiment over and over and over again. It doesn't matter if I always pick the same egg from the same spot or if I pick a random spot each time. Mathematically and probabilistically, it doesn't matter. And this drives our son crazy. When he was younger, he used to play this game called Dad, Guess the Side, and he'd flip a coin. And I'd always guess heads. And he said, Dad, you always guess heads. And I said, it doesn't matter if I always guess heads. It's the same as if I change it all the time. As a matter of fact, I don't even have to look at the other 11 eggs. All I have to focus on is egg number 3. See? It's in the same position right there. And what I'm going to have Excel do over here is I'm going to have Excel, every time I re-randomize, keep track of the results of what this egg is. So every time I'm pressing the F9 button, you're getting a new trial with a new dozen eggs. And the position of those eggs is being kept track of in Excel, in both these sheets. But Excel is just tracking egg number 3. Since I used egg number 3, again, because of the fact that most of Fallon's guests seem to grab the egg from this point. So what I'm going to do now is I'm just going to hold down the F9 button, and I'm going to let this thing run for a while. And we're going to watch the data as it begins to kind of move around and then stabilize. And then we'll regroup. Okay, friends, I think this is probably enough data. Hopefully you've noticed what we're seeing right here. 33% of the eggs that were here, so that's 6,709 eggs out of the total of 20,146, 6,709, which is 33%. Now, it's not exactly 33%. It's 33.30%. Were raw. And 67%, or 66.70%, were hard-boiled. Now, those numbers should sound familiar to you, right? Those numbers should sound familiar to you because 4/12 or 6/18 are both equal to 33%. Now, I mentioned earlier, you do have to have a margin of error. And the margin of error on these statistics is extraordinarily small. There it is right there. It's less than 1 percentage point. So you can trust this value to within 1/3 of a percentage point based on margin of error. And that's kind of the point, is the more trials you run, the better you feel about the result. But the big picture, the big idea really is, what is that number telling you? What does 33% tell you? What does 67% tell you? Yeah, it's the probability. Yeah, it's the chance. Yeah, it's the likelihood. But what it really tells you is something that should sound familiar to you. It's the percent of the time that this event happens. 33% of the time, the person going first is going to get a raw egg. 67% of the time, the person going first is going to get a hard-boiled egg. It gives you an idea of how often something happens. That percentage will show itself over a long period of time. And that's the big idea of probability. Let's look at some more examples.